Hey folks, today we're at the Fisher Delta Research Extension Center, and we have a few of the folks that work in the soybean breeding program. The one's a PhD student. Now your name is?
So my name is Harmeet Singh. I'm a PhD student working in soybean breeding and genetics.
And your specialty is flooding, right?
Flooding, drought, and also the photosynthesis.
Oh, wow. And you're trying to develop varieties using technology that can avoid drought, for example.
Right. So we want to see screen the material using the high throughput phenotyping technologies like drone and also the multispectral camera imagery and also some other devices with the handheld devices so that we can see the differences and select the best varieties who perform.
So using high tech to get your screening that might take years to do.
Right, conventionally.
All right, now you are a postdoc from Madagascar. All right. So what brought you here?
I did my PhD in Arkansas. On soybean breeding. I was mainly working with abiotic stress. Then I got the job at the University of Missouri. Then I'm leading the abiotic stress program.
Abiotic stress like drought or flooding.
And also dicamba.
Herbicide.
Really? Herbicide.
Yes.
So you didn't send the same work, except you're focusing a little bit different then.
Yes, like our program is like divided like in mainly 3 parts, like abiotic, biotic, and then like seed composition.
All right. So what brought you here? Dr. Lynn, right? Both of you, right? Right.
So I did my master's in India in plant breeding and genetics. I wanted to do my PhD in applied breeding stuff as well.
Sure.
So I applied for some good places in the US, and soybean is really the very good crop I wanted always to work in because I didn't have any experience in soybean. So that's why University of Missouri brought me that opportunity to work here.
And probably Dr. Lynn has a lot to do with that too. He's a great scientist.
He's a great scientist.
Definitely.
And this facility here is really a lot of nice facilities.
Yes, we do have a greenhouse. We have a lab for seed composition that do the gas chromatography. We will try to build a molecular lab too in the future.
Oh my goodness! So you're going from the field and molecular biology to put this all together.
Yes.
Also updating our greenhouse for like updating some like AI assisted things so that we can do some experiments off season as well, and also getting the drones into our experimentation.
Yeah, because you all mentioned that by using your drones, you can cut a few years off this whole process.
Yes. Yes.
Ultimately, what you want to do then is to develop new lines that have resistance, and maybe even these would be germplasms that other people could use too.
Yes. So, for example, for the flood, we have to release a germplasm that every university or public or private can use. It's available for the public. But we do also have some cultivar commercial variety that will be available for farmers because they have a special traits. Like a high oleic, for example.
Oh, that's right. Because you do that too, don't you?
Yes, we do also high oleic soybean. And we start to do the Extend Flex also this year for the herbicides.
So you start to do those?
Yes.
Okay, great. Because you're doing a lot of conventionals right now.
Yeah, like I think like 80% now is conventional, but the goal for the future is to do 50 conventional and 50 like Extend Flex.
Sure, because now your food grade ones, like with your high oleic, you probably want to keep some of those conventional, don't you?
Yes.
I think it's fascinating, these abiotic traits that we can't control, but if we have that resistance, or that tolerance, I should say, it really makes a big difference. And I know each year we have some drought issues. I've replanted a lot of soybeans in my life from being drowned out, so this and lost a lot of yield because of it. So this is really, really great. Thanks so much.
Thank you very much.